Farnborough, the birthplace of British aviation. The experiments and research carried out here led to the development of some of the most influential and famous aircraft ever to take to the skies. Now a historical hub for powered flight in this country, let's explore the aerodynamics and wing design that happened right here. Welcome to Farnborough's aerodynamic journey. Aerodynamic research in Farnborough started in 1908, when what we now know as the Royal Aircraft Establishment, the RAE, was founded. This was after Samuel Franklin Cody's first UK-powered flight, back on the 16th of October 1908. This paved many aircraft designs, like such things as the Delta Wing, which Dr. Jean Ross helped on.
I came to work in aerodynamics department here at RAE Farnborough in this building in 1956, and about 6 months after I started, the Supersonic Transport Aircraft Committee was set up, which was the beginnings of Concorde.
A new aerodynamic problem for civil airliners. Shockwaves. A Schlieren film records the shockwave formation at supersonic speeds.
And work had been going on in aerodynamics department to sort out what sort of shapes could be efficiently used, and the slender delta was chosen as the way that might be able to cope with supersonic transport for carrying passengers. But one of the difficulties was that at low speed, the sort of speeds that you needed to come in to land, the aircraft would go into an unstable rock.
This is the Q121 building, and it was where the majority of the testing was conducted. It was constructed back in 1939 and was last operated in the mid-1990s. But now it is a Grade 1 listed building. And finally, there is the R133 building, which houses the transonic wind tunnel. This is used to test planes like Concorde up to Mach 1.25, or more commonly known as 926 miles an hour. It was developed during the Second World War and housed many different plane developments. Wind tunnels are used to test the aerodynamics of planes and other objects. They work by having a big propeller suck the air through the tunnel with the object inside while it's being filled. And then aerodynamicists later on review the footage and then see the lift, the shock waves, and the drag, if they're looking at an aeroplane, for example, so they can make improvements to their designs. But on the other hand, you also have the engineers who sit up in the control room, making sure the experiment runs smoothly and safely. But they also do their own experiments regarding buildings, bridges, and even telegraph poles, to see how they cope in strong winds.
My name is Richard Bruce. I'm a volunteer for FAST Museum, carry out tours of the wind tunnels. I actually worked in this wind tunnel and a number of others in the RAE. I was a mechanical engineer, so the mechanical engineers generally looked after rigging models or rigging whatever the test subjects were, doing instrumentation, and then actually driving the wind tunnel. The clever guys, the aerodynamicists, would have been taking data and analysing that data. I worked on the A320 Airbus, which is typical holiday jet. Very often, they'd analyse what data was available from previous tests or what the requirement of whatever the future program might be, i.e. what sort of speed range it was going to fly in, what sort of loads it was going to carry, whether it's a civil or a military application. They then get that drawn up and go to the model shop, and the model will be fabricated either out of wood for low-speed testing or alloys, steel alloys, aluminium alloys for the higher speed stuff. And at that stage they'd also decide what sort of measurements they're going to take. So normally in a wind tunnel test you measure the forces, the likes of your lift, drag, side force. But they also take pressure distribution measurements, so there's very small static holes drilled in the surface of the wing. So they look at the pressure distribution across the wing, and they also may look at flow visualization, like putting woolen tufts on the model or mini tufts. And then we'd actually run the wind tunnel, and the clever guys, the aerodynamicists, would be taking the data, and from that data, from that campaign, they would write a technical report for industry or the MOD, whoever are interested. And that process could take up to 2 years. Well, really, Farnborough and RAE has been involved with almost every stage of technical change in aircraft and wing design. But a lot of it was done at Farnborough, and actually some of it in this wind tunnel. Mostly over the road in the 4x3-foot wind tunnel. An awful lot of Delta research was done there that was later used on the Concorde program. So various Delta planforms ending up with a slender planform that we all know from Concorde. Historically, all sorts of aircraft that you'd recognise were tested in various tunnels here. More recently, things like Harrier, Tornado, Jaguar, Eurofighter. So they did a lot of development work on the flaps and slats that you see extend from your holiday jet when you're looking out of the window, and then they're all stow away for the cruise aspect of the flight. So a lot of that research was done in the wind tunnels here.